Let's look at the addition, subtraction, and the scalar multiplication of vectors. We are given two vectors, u and v. The two components of u is denoted by u1, u2, and xy components of v is denoted by v1, v2. Here, u1, u2, v1, v2 are real numbers. And c is a real number as well. So for the addition of vector u plus v, then you do is basically add these two components respectively. You add u1 and v1 together. You add the second components together, u2, v2. Okay. And u minus v, then you do is using the first component, u1 minus v1, and then u2 minus v2. Okay. For the scalar multiplication, means c is not a vector. C is a real number times the vector u, so you just use c times u1. Okay, and then the second component will be c times u2. So it's quite easy. Now here is the example. A is 1, 4. So 1 and 1, 2, 3, 4. So this is our A vector, vector A. And B is 3, negative 2. So 1, 2, 3, and negative 2. So this will be B, like that. If we do the addition, A plus B, then will be 1 plus 3, which gives us 4. And then 4 plus negative 2, which gives us 2. So this will be 1, 2, 3, 1, 2, 3, 4. That's the first component, or x component. And the y component will be 2, 1, 2. So this is the sum of two vectors. A was here and B was here. If you draw a parallelogram, then the sum of AB is actually the diagonal of this parallelogram. You may also think in this way, is that if you shift our vector OB to here, because two vectors will be equal if they have the same direction and they have the same magnitude. So basically O and then B, let's say this vector will be equal to this vector starting from the point here and ending here, because the length stands for the magnitude, they are equal, and the direction we can see clearly is the same. So basically this is vector A, this is vector B, and then A plus B end up, the starting point will be the starting point of this vector A, and the ending point will be the vector B's ending point, if this is the vector B. So if you look at this triangle, this is vector A. This dotted vector will be equal to vector B, and then the sum of the vector will be this vector. Okay, so the starting point is the same as the first vector, and the ending point will be the same with the second vector. This is basically the rule for addition. So you may think this addition in two ways. One is in the parallelogram, the sum will be the diagonal. Another way is that if you look at this triangle, then the sum will be the starting point of the vector is the starting point of the first vector, and the ending point will be the ending point of the second vector B. So that's for the addition. All right. Next time we'll talk about subtraction.